Perfect. Okay, so I think we're live. I have a question, and maybe I'm not understanding this. So I did the quiz, and I don't know how right or not. And then I got stumped at 14. But I guess I'm just not really clear on what I'm looking for in the Q plots.
Okay. Question 14.
I mean, I guess we could get there. We can start.
Oh, yeah, I see. Well, yeah. We'll get there, but
okay.
I think I know what's going on there. I think. We'll find out.
Okay. Okay, so question 3, I put true.
Yep, that's what I put.
Okay. And then question 4, I put data in each group are normally distributed and variances are equal in each group.
Mm-hmm. Yep.
Okay. And then 5, I put construct a QQ plot for each group.
Mm-hmm.
So then 6, I put the largest variance is less than 4 times the smallest variance.
Yep, that's what I got.
Okay. And then 7, I didn't know how to figure this one out, but I said 6.
I put down 6 as well, so I think we're on the same track. Basically, yeah. So you know how like
I just did it by hand though.
That's all I did too.
Okay. 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 Perfect. So I'm okay. That makes me feel better. 8, I put group C or 27.208.
Mm-hmm. Yep, that's what I got.
And then question 9, group D or 53.158.
Yep, that's what I put.
Oh my gosh, I can't believe this.
We are rocking.
And then number 10. Okay, this is where I put false, but I don't know if that's, I'm not understanding that, I guess.
I put true, but let's see. I'm wondering why. It says the tests for equal variances is satisfied for these data. Oh, yeah. So the test for equal variances, basically it's like if the smallest variance, so you have a whole bunch of different variances.
Right. Is 4 times.
If the smallest one is, or no, the largest one is less than 4 times the smallest one, then it's still okay.
Okay.
Yeah, so I think that's right. This is the soccer shoes one. Yeah.
Yeah.
So I think it's true.
Okay, I'll go back and look at it too, I'm sure. Okay, then it says construct a QQ plot for each of the 6 samples. Each sample are approximately normally based on what you see in the QQ plots. I said true.
I put down true, yeah.
Okay. And it said perform the ANOVA test. What is the p-value when you remove the socks after you do it and then you remove socks? I put 0.309.
Yep, that's what I put.
Oh. Okay. And then the test statistic for an ANOVA hypothesis test is an F statistic. If the p-value, the area to the right or the left. I said the right.
I said right. Yep.
Okay. Okay. Now this is where I'm confused. It's 14.
Okay. So there's 2 things that have to be true in order to do. Well, let's see here. Yeah, in order to do a ANOVA test, there's the 2 things you have to have normal distribution for all of your data, and that's you do through the QQ plot, which is that little line, you know. So if all of those are normal, and then also the variances are assumed equal, meaning that one thing that we were just talking about, how like if the highest variance is less than 4 times the smallest, then you can still assume that they're equal, even if they're, you know, different numbers.
Okay, so when I'm looking at the QQ plots, they look fine to me.
And that's what I thought too. I thought that they were all normal. There was one that might have been a little bit off, but for the most part, they were pretty spot on.
Yeah. Okay. And then if I look at my variance, now when you did it, you had to run calories separate from sodium, right?
That's right.
Okay.
Yeah.
That took me forever to figure that out. I was trying to do them both at the same time.
Yeah.
Sometimes the instructions are a little vague. Okay. So then, or at least for me. Then when I look at
that's the same.
Then the variances, I just look at the descriptives, right?
Let me get to my hot dog thing here. Let's see what I've got. Calories for, oh, no, this is soccer shoes. Just kidding. Well, this is.
Calories, or is this one my? That's my sodium.
Yeah, so for the variances, you look at the.
Like the mean, the 95% interval, like that whole list of stuff.
Well, what I did is I just looked at, I did mine on Excel. Did you do it on SPSS?
Yeah.
Okay, so it's probably going to be a little bit different, but on Excel, it actually shows you right there what each variance is for each
And mine
thing.
does too. It just gives you a whole bunch of other junk too.
Oh, okay, gotcha.
Okay, so like the beef comes in at 512.661.
Let's see. Hang on. 5. Which one?
Beef.
Oh, you know what? I'm looking at sodium. That's why this is off. Probably. That's probably right.
So I'm just taking them. So that one's like 512. The next one is 636. And the next one is 508.
That sounds familiar. I think that's what I got when I put it down initially.
So they're all within each other. So you're not over four times.
Right. Yeah, you're totally fine as far as the variances go. So for the answer, I put down the assumptions have been met.
Okay. So
because A.
Okay, so then it says run an ANOVA test. Determine if the mean number of calories is the same for all three types of hot dogs. So the mean, is it just, okay, is that, let me see, mean. So I'm getting 156, 158, and 118, but that's still within the 4 times, so we're okay, right?
Yep.
So we say we have sufficient evidence.
Yeah, so
Again?
P is equal to 0.000, level of significance 0.05. So yeah, since P is less than the level of significance, then we do have sufficient evidence to claim that at least one of the hot dog types is different.
Okay.
So I put down D.
D. I am so confused. Okay, so tell me how the P and the F are factoring into this.
So I'm not too sure about F, on what F really represents. I didn't quite understand that, but
you know, P is less than 0.05.
Exactly, and I think that's what it's asking right now is where does the P-value relate to the level of significance?
Okay, I'm sorry. Okay, we'll find out, right?
Yeah.
Okay, so then we do sodium.
Yep. So I've got those numbers up here so we can compare those.
Sodium. Okay, so for sodium, the variance is 10,492, 8,812, and 7,180.
Yep.
So those should all be good.
Yep, those are all good. They were saying in the question that they suggest a possible problem with the normality assumption. So basically what they're saying is there's some sort of a QQ plot from poultry. The sodium plot for poultry is it's possibly not normal.
Yeah, because it's that bottom one falls kind of low.
Yeah, it's a little bit weird. And so, I mean, it looked like it was good, but since it said there was a possible problem and I could see that there could be a problem, we don't really know if it's actually normal. Like it could possibly be abnormal.
Okay.
And so because of that, and I don't know if this is right, but I kind of went off on a limb and I said that the assumptions have not been met. So answer C. I said the assumptions it's not been met because it's not safe to assume that each group comes from a normally distributed population.
Okay.
Based off of that QQ plot, that's kind of wonky. But we can assume that the variances are equal because of that other thing.
Yeah. Okay. Perfect.
Yeah.
Well, this says, despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all 3 groups. what is the p-value for this test? So how do I figure out the p-value when you've done them separately?
Well, I just plugged in the numbers for sodium, and I ended up with 0.179.
So what do you mean you plugged in the numbers?
So on Excel, there's that one sheet, the quantitative inference procedures Excel sheet that I showed you, I think last meeting. Anyway, there's a little tab that says ANOVA at the bottom. And so I clicked on that tab, and you can plug in your variables. And anyway, the variables that I have up right now are just the variables for sodium.
Okay, so let me pull that up really quick, my sodium. And I guess I'm trying to figure out how I can figure out my p-value. Oh gosh. Sorry, bear with me for a second.
Oh, that's okay. Yeah.
Get to sodium again.
Yeah, it's nice on Excel because it just shows you the p-value right there on the sheet.
Which one am I on? Sodium. Okay. So I'm just trying to see if there's something that shows me p-value. P-value is the sig, right?
P-value is the sig. What do you mean by that? Sorry.
Oh, how to define it in SPSS. You have your degree
Oh,
in SIG or SIG.
gotcha. Yeah, I'm not really sure because that.
What was your answer for sodium?
The p-value that I got was 0.179.
179 for sodium alone?
Yeah, so what we're doing is we're plugging in the variables for the mean sodium levels.
The mean sodium levels. What is the p-value for this test? Sorry, I'm just trying to see if I can find something that's comparative to that answer so I kind of know what I'm looking for.
Yeah, that's fine.
Sorry, gosh. And it's just for poultry that we're looking for?
No, we're doing it for beef, meat, and poultry, but we're plugging in. So what the question is asking is, it says, despite the possible problem with the QQ plot for poultry, you decide to do the ANOVA test anyway. So basically what it's saying is even though you might think that the QQ plot is off, that it's not normal, you're going to go ahead and you're going to do the ANOVA test anyway. That's kind of what it's saying. And so you take the beef, meat, and poultry levels of sodium, you put them into the ANOVA test variable slots, and you get all your numbers. You get your mean, you get your standard deviation, you get the variance.
So I have all that. Do you care if I share my screen?
Yeah, go for it.
And tell me what I'm looking for. I guess I'm just not understanding. So hang on.
Yeah, and I didn't do it on SPSS, so it's possible that it doesn't even show up. So if not, then we can. I think you can calculate it, and that's okay.
I guess maybe that's what I need to figure out too. I can't remember what the formula is. So can you see that now?
Yes, I'm looking at it. So I see the N, I see the mean for beef, I see mean for meat, mean for poultry. Let's see. Does it not?
Total.
I'm looking. So the number that I had was 0.179. Let's see. I'm looking at degrees of freedom I'm just kind of comparing yours with mine with what I had. The beef statistic 0.156. I'm trying to find that on mine. I'm not sure. I'm not finding it. Yeah, the thing is, I'm not really sure what SIG even means.
Okay.
I don't really know about that one.
I wonder if it doesn't show my QQ plot, does it? No.
No. Go up real quick. I want to see what those numbers were. Let's see. Frequency. I'm trying to see if there's any numbers that look familiar here. No, none of that really looks familiar. No, go back down again. Sorry. Let's take a look. Is there anything below the QQ plots?
Okay. My, what do you call those boxes?
Oh, those things. Yeah, no, I don't think anything's going to be there. Is that it?
And then when I'm looking off to the left just to look at my ANOVA, it usually puts it in its own little box. It's not putting it in its own little box. Huh.
Well,
Test normality. It's got to be this, right? Test normality is what I'm looking for.
right. Let me just look it up really quick. Let me see what the formula is for the p-value.
Sorry.
I can just search it really fast. No, that's all good.
And I'll call him in the meantime. Maybe he can give me some help.
Yeah. Let's see what it says here. P-value. I think what it is, yeah, I remember what the p-value is. So what you have to do is you have to find t, your t-score, and then from your t-score, you put that into the
Probability
applet, and you have to highlight the far ends of both sides, the right and the left.
Uh-huh.
And both of those together is the p-value.
Okay.
Yeah.
Okay, I'm going to call him and ask him how I do that on SPSS. Okay, so what was the answer that you got, if you don't mind?
Yeah, so the answer I got was 0.179.
79. Okay.
Mm-hmm. So actually, I'm curious. I wonder, I don't know if you can actually get a t-score with the stuff that we're doing, so I wonder if F plays into, because this lesson is talking about F.
Right. I'm not even seeing F. Am I blind? Hang on.
F statistic. Yeah. I bet you F statistics are basically like T statistics, test statistics.
But I'm not even seeing where it's showing me F.
I'm looking in the book, lesson 14. It's 3.1 F distribution.
No, I was just meaning on SPSS, so they gave me the F.
Oh, well, I don't know about SPSS, but on Excel, there's an F score or an F distribution. I'm not sure what, there's a number for it.
Yeah, what lesson was that? How to run it?
I'm looking through it and I can't quite tell just yet. It might have been lesson 13. Anyway.
That's okay. I can just ask him. That might be quicker, and then it'll save us all a headache since you don't use SPSS.
Yeah.
You know?
Yeah, it's kind of a weird animal dealing with SPSS.
Okay, so it says number 18. What conclusion can you draw about the mean sodium levels of all three type of hot dogs? Use a level of significance of 0.05. So it's more, their p-value is higher than significance. So that means that
right.
I always get confused.
So if it's higher, then you fail to reject the null hypothesis. And so right now, I think we're saying that the null hypothesis is that they're all equal. Okay. So basically, we fail to reject, or we have insufficient evidence. Well, let's see. It doesn't give us insufficient evidence for an answer. I put down C, but I know that's wrong now because I read it wrong.
Oh, okay.
So
is it B?
B?
Yeah.
We don't have sufficient evidence to reject the claim.
Oh, we want to reject it though, right?
Well, since our number is higher, which it is, then the level is significant.
Oh, we failed to reject it.
We failed to reject it. So I think it's B, yeah. Because that's the only one that says we don't have sufficient evidence to reject the claim.
Okay, I guess we'll try it.
We fail to reject the claim that all three hot dog types have the same medium sodium levels. I'm pretty sure. That's got to be it. That has to be.
Okay, do you have your answers in?
I do. I can go submit it right now.
Okay, I just don't have mine in. Hey, stop. My kids are ringing the doorbell.
Oh, for a second I was thinking that was my doorbell.
No, they just like to do it because they drive me crazy. They're too lazy to walk to the back door.
Oh, hey, we got 100.
Woohoo!
Check that out. That's cool.
Okay, so there's only one I'm stumped on, but I think I could probably figure it out.
Okay. Was that 17 or which one was that?
Yeah, 17. I'll figure it out.
Yeah. I wish I could help you because
That's okay. Everything else, we were spot on. I didn't have any questions. So if it's one that I have a question, I can deal with that.
Awesome. Sounds good.
Okay, so how does it work for Thursday? Are we supposed to meet again, or are we just on our own for the?
Oh, I don't know. I'm afraid I haven't even looked ahead. What's going on Thursday?
So, well, we have our exam this week.
Is it this week? I didn't even realize.
Let me look really quick. I'm pretty sure. Sorry. Can you stop, please? Yeah, so Unit 2 exam.
Oh.
It still says group meeting, but what are we meeting about? Are we just meeting about the pre-exam?
That's a good question. I don't know. Let me sign in here and see if I can.
I thought I read something saying that we didn't have to meet, but I have so many classes that it's just kind of all.
Right, kind of blurs together a little bit. Let's see.
I guess I can go to the main page.
Group meeting quiz. Oh, group meeting. It says there's no homework for this lesson. Instead, review the readings, homework exercises, and other activities as you prepare for the upcoming exam. So it looks like there is a quiz for lesson 15. We just don't have homework. So pretty much we're going to meet normal.
Okay.
I think.
Okay. And just go over. If we have
When does that exam close?
Saturday, I'm pretty sure. Let me look real quick.
Okay. Yeah, if it's Saturday.
November 3rd. When is November? Oh, no, that is on Thursday.
Well, it says it ends November 5th, as it looks like.
Oh, November 5th. Oh, yeah. Sorry. It starts November 3rd. So, yeah, Saturday.
Okay, gotcha. Yeah, so I think we'll just meet normal on Thursday.
Okay. I'll try to get as much as it done as I can. I can have a crazy week. But.
Okay. Did you need help with getting those answers in? Because I still have the quiz up right now. I can just.
No, I print it on paper first.
Okay. Sounds good.
All right. Okay, Dakota. Awesome. And you're going to email over to Alan?
I will. Yep.
Did you get my email last week about how to do that problem we couldn't figure out?
Yes, and that was super, super helpful.
Okay.
Thank you for sending that to me because I got a little bit stumped on the homework. It was the same kind of a deal. And yeah, I did the same thing that you said, and sure enough, he was right. So.
Okay, good. I was hoping I'd catch you before you submitted your exam the second time, but.
Oh, it's okay. As long as I'm passing.
Yeah, I'm becoming a firm believer. C's get degrees. I have to get a B at least on this test. Yeah. I know it. That's the thing. I know it, but I get on the test and I'm dumb. Anyway.
Stuff happens.
Okay. All right. Perfect. I'll post.
Okay. Sounds great. Thanks so much.
No problem. Okay. See you on Thursday.
All right. See ya.
Okay. Bye.